Doesn't even say a word. That was the first part of point 3 in the description below the video. It's intrusive. A dereferenced iterator will return a type that is the user data type. Second part. But it is also derived from a node clause that has pointers to the previous and next element. So we need a node clause. I guess I'm gonna call that utils list. Let's just use the list type. I'm gonna use a node. Just define it inside a list again. So this should be possible. Okay, now we have a problem. I think that instead of, the dereferenced value should not return a t, it should return the value type, which is currently t. It definitely should return a value type. So this t is actually value type, and this too. And I think this as well. just the pointer, underlying pointer of the iterator. But then I need a class that contains both the node and the T. And like, yeah, and it must be by inheritance, because I want to be able to assign this directly to the T type, not necessarily the node. That means, I mean, this must become some other type. Let's call that. It's a combination of the user data type and previous and next pointers. I think I usually call that a node. Although on the other hand, usually data is derived from node. Go call it data. So I'm going to have class data, which must be derived from T. T can have any kind of constructor, so it must be the case that the data, the constructors of data is, how do you do that? Just using TT, I think. So any constructor of T becomes the constructor of data. Which seems to mean that I can't derive from node as well here, because I'm not sure how much this makes sense in that case, or yeah, maybe if node is just a default constructor. But I don't think it can be a default constructor, so we have to construct that as well. This is slightly problematic. Yeah, it can be constructed afterwards. So maybe a default constructor is possible. Otherwise, you could put a node here as well. Why not? So these are the previous next pointers. With the advantage that theoretically you could put a node at the end. I don't know if that is an advantage, but then from the point of view of the user, the data is really just the first thing. It was that already. That's nonsense. But Oh, that's nonsense. I'm not sure I want to do this or just derived from node. Let's derive from it. I mean, yeah, I don't know. If deriving works, then why not? I could always make it private. Nah, and then I can't access it. I want to be able to access it from data somehow. Could make it protected maybe. I also think that the node must be... Well, the node is part of list, so it already has t. It knows t. So let's do this like that. Same holds for data, actually. So this is just data. Or the same way here, we just call that iterator. Might as well leave this out. Call this value type. So instead of having using value type is t, we have now it is t, but then we add a node to it. Let's see what breaks. Inaccessible base of value type. Yeah, that is true. I changed this. Well, it is derived from node, but it is protected, so then I still can't do this. This is not the correct way to test it. But it has the node. It's derived from it, so it protected, so the dereferenced iterator is able to access it. Which means that, let's say we are able to get the previous and next iterator. The usual way. I want this to work. Going to give a lot of errors, so let's begin with commenting it out, except the first one. Yeah, I'm not sure my iterator is a real iterator. I can't do this even. Let's have a look at the list again. To the iterator of a list. It's a legacy bidirectional iterator, to value type. A legacy bidirectional iterator is a legacy forward iterator that can be moved in both directions, incremented and decremented. For legacy bidirectional iterator, it originates from a container, then its it's value type is the same as the containers. So dereferencing it obtains the container's value type. Yep, that is what we already do. Requirements. If the it satisfies legacy bidirectional iterator, if the type it satisfies legacy forward iterator, and given a and b, else values of type it, and reference, the type denoted by standard iterator traits it reference. And how is that defined then, out of the blue? The following expression must be valid and have their specified effects. No, let's see if this even exists. Hardly imagine that this does not already exist. Wait, is er another one? Yeah. 8 years ago. You have to tell it that this is a type name. I mean, it's a using. There is a reference for const iterator. Yeah. Wait a minute. Pointer is a pointer, value pointer. Yeah, so that's exactly what I don't want to do. Or maybe I should just you do the const cast stuff here. Right, so advance it's called. If you call standard next. But this apparently this just calls operator plus plus on the operator, on the iterator. That's pretty annoying. We have to repeat all of these things for both iterators. Const iterator and the normal iterator. Totally want to avoid that. But yeah, this returns iterator, so in this case it must return const iterator. And in the other case it must return iterator, so I really have to duplicate all of that. Now then, apparently pointer must point to something that has a next pointer of the same type as pointer. In other words, my value type must have a value type pointer called previous and next. And the value type is the list value type, and the list value type is this thing, which then means that the node must have a value type pointer called next and a value type pointer called previous. Which then must be forward declared. And now the value type is then non-const. At least it gives access to non-const stuff. But it's non-const itself, so that's not really the problem, I guess. So I would get yeah, it's a non-const value type pointer is being assigned here. But that's okay, even inside const iterator, because we never allow access to it. The only access you get is in terms of reference and pointer, which are both const for the const iterator. Pointer was not declared in this scope. It starts to get annoying. I think it kind of reads a bit weird. We use const iterator everywhere, so it's more like the base class. Let's just use do a using. Let's make it private. In instantiation of utils list t allocator iterator reference utils list t allocator iterator operator plus plus with t equals data and allocator is then allocator data. Required from required from required from required from error. Is private in this context. Next is private. Oh, that was not my intention. Declare private here. Yeah, to make this a struct. I really don't care about the safety of those pointers at that point. Now what? The same thing is still required from here is inaccessible in this context. It's not private anymore, but just inaccessible. Seriously. Oh, like that. Yeah, I get it. Because this is a value pointer. Okay, let's look at the source code and meditate on that. Yeah, what? No, just access to next. So pointer is a value type, it's a list value type, which is this value type. And then we can't access node because we derive from that protected. Okay, I'm thinking about dropping the protected or not. The reason I wanted to make it protected is so that the user getting value type is not allowed to directly access next and previous. Clearly, because if they would change it, and they're not allowed to change it. They're theoretically allowed to read it because you can read it. You can get access or read access anyway. But I don't really want to give access to it. Not really. So maybe with the front end, if I keep the protected, because clearly the one that does need access is this class, or at the very least the iterator. This thing. So yeah, class iterator and cons iterator. Must both be. I really hate this duplication. Can I get rid of this duplication here? This returns const iterator. Could just make an inline function that casts const iterator to iterator. Then I only have to implement this here. That's what I'm going to do. I don't want to have any implementation here. So this is going to return a static cast to iterator reference of call to this same operator of the base class. Yeah, I don't want to pause a 0, really. Just to get an int. So instead I want to use the plus plus in front of. So I guess what I have to do is cast this to the const iterator and then call a plus plus operator on that. So it's a plus plus of, I'll just use a static cast here as well, even though that's kind of, well, weird. Yeah, so we cast it to the base class. This is of course an iterator reference. Well, this is the pointer in front of it. Yeah, maybe just cast it to the pointer. So this is a pointer to iterator, and I can cast that to the base class as a pointer. And then if I want to use plus plus, I still have to dereference it. But okay, that doesn't look very nice either. Let's just use a reference and use a star here. And then the return type of that is a const iterator, so we cast that back to an iterator as per allowed, because they are just derived from each other. And then here we can do almost the same thing, except that we put the plus plus on the other side. Nou ja, and then again. I could do the same thing here, but yeah, I mean, it's not going to be shorter than it is now. So now I only have to make the const iterator a friend. Or not. Still inaccessible. How would it be inaccessible then? Oh, I added a friend to the wrong thing. No, I shouldn't add it here. In order to access the protected base class, you have to add a friend here. So kind of friend to protect it away. That compiles, yay. Okay, release test. So now I can do this. This comment is now, I mean, I'm just implementing stuff so that the comment that I added in the description of this video is fulfilled. And then we have something that is not working, but at least then everything is fulfilled. That is mentioned in the comments. After that, I have to make it work. But we do have a previous and next pointer now. And this was kind of a test for that. And I think that everything else immediately works as well. Yep. So yeah. So a dereferenced operator will return a type that is the user data type, but is also derived, but it is derived protected, so I couldn't assign it from node class that has pointers to the previous and next element. In other words, the dereferenced iterator must be derived from the node class. And we did that because the dereferenced iterator returns a reference, which is a reference to the value type, and the value type is list value type, and the list value type is this thing, which is derived from node class, which has a previous and a next pointers. So yeah, we did fulfill that comment. Point 4. It must be testable if an iterator is the end iterator without having access to the list. This is new. I mean, the standard list cannot do that. Now you would say, well, that's easy. You just make it a null pointer. If next is null, then it is the end. However, point 6 says it must be possible to insert a new element before any given iterator, including begin and end. So suppose I have an iterator that points to end. Then maybe previous is still pointing to something that I can use to insert before it. Let's see, we have think. Yeah, why not? It's actually not a problem. I don't think it's not a problem, is it? No, it's not a problem. So we can make end detectable by having next be a null pointer, I think. But then previous is definitely not allowed to be a null pointer. Otherwise, yeah, we don't know anything. If you just have the value type. Continue. In fact, I want, it's not even in my list, I think. The reason that it is intrusive, that is that the value type includes the previous and next pointers, is because I want to be able to access the previous and the next element, but also, of course, that it is testable, that they exist. So the value type itself must have an accessor let's keep it a pointer, why not? I mean, it's a pointer here. Could turn it into a reference, but nah. I think it's more clear as API, as the programming interface to return a pointer when the original was a pointer anyway. So I'm going to return a value type pointer from something called next. And a const one if the current the value type is const. So if the current value type is const, then you can only get a const pointer to the next and the previous one, previous values. Let's put keep previous before next. Seems logical. So adding these member functions was the whole point. But it still must be testable if the returned value is valid. Which means that I do not really want to return a pointer to a value type. I want to return iterator. Therefore, we can't define them because iterator is not defined yet. And then this must be iterator, and this must be const iterator. Which means I need to for declare iterator anyways. And but I do want them to be inline, so I'm going to mark them as inline. Come on. And then if everything turns out correct, I can define them as soon as we define the iterators. Thus here. No, probably not. You have to put them below the class. But yeah, let's put them as high as possible. I'm gonna put them here. No need to repeat inline. And they are part of the value type, right? Yeah, value type. They are part of the value type of the list. It's this value type. So and the list is a template, so we get the same thing as here. Yep, and also the iterator and the const iterator types are part of the list. And then we have to implement them. Now my iterator and the const iterator, they are just a pointer. So I can construct them from a pointer. So I'm just going to construct them, but that is explicit. That must be explicit according to Claude. I think I saw that somewhere. The constructor of an iterator. Iterator, yeah, explicit. So I can't do this. You have to explicitly mention the type. And then pass something, of course. But I'll do that in a second. Now also there are types. Yeah? There are usings or type defs, and these are templates. So this is a template, and then we use a type. Then you have to put type def in front of it. Type name, I mean. Otherwise it doesn't know that you're talking about type. And yeah, I can just construct those things, I suppose, from whatever the pointer is. We have a pointer to value type. So then here we need so this is the value type, which is derived from protected node. Therefore we can just access the pointers directly. So previous is a value type pointer. And if not, then we'll get compile errors, I suppose. Let's see what this gives. Allocator is not declared in this scope. For some reason they are called alloc here. Where did the allocator come from then? And here I call it allocator. I don't like abbreviations, so let's just rename all allocs to allocator. Really? Oh, previous was not declared in the scope, so I made a thing go somewhere. We are inside value type of the list. Here's my list, here's my value type. Inside of it we can definitely access the protected node, which defines previous underscore. So what's the problem? The only thing I can think of is that this is one of those cases where you have to explicitly use this pointer. I would have no clue why, but that's the only thing that comes to mind. So let's try that. Yeah, that was it. Okay, so I have no idea what I just did. Oh, we are, I think I was implementing 0.4, right? It must be testable that an iterator's end, yeah. And then I remembered that I also wanted to have this previous and next access. So I could make that a new point, having just the value type. It must be possible to access the previous and next elements. So that is get an iterator. So the list type iterator. I want to call it iter. I'm not using iter here. Yeah, I am here. Well, okay. I'll call it iterator 2 then. Whatever. No, wait. Let's make a value type. Reference. Called value or whatever. From the iter. Now we have a value type. And then I must be able to get an iterator. From value. Redeclaration. Oh, we already have a next iter here. So annoying. In instantiation of utils list blah 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 value type next, quite from here, could not convert value type pointer this utils list data value type utils list data node utils list data node next from value type pointer to const iterator. Ah, yeah. Why don't you say that immediately? So we go back to the list. Yeah, I'm trying to construct iterators there from pointer, but never added that constructor. So we need a constructor. The default constructor just leaves everything undefined. As in, where's my pointer to begin with? The whole thing doesn't even have a pointer yet. I have a PTR there. Okay, I'm so confused now. Oh, here it is. Sorry. So that PTR is just pointing to oblivion. If you make if you use a default constructor, that's okay. Yeah, you would say make it an end pointer, but nah. I mean, what can we do? The only thing you can really do is make it a point to null, because it's a default constructor. We don't have anything. We don't even know what list this refers to. Okay, this is actually a problem. I was mistaken a second ago. I said that we could use the next pointer to point to null to detect if an iterator is the end pointer, but I was looking at the node of a value type, but the iterator only has a single pointer. So I can't make that a null pointer and then say that's the end. Normally people do that, but the standard is doing that. No, the standard is not doing that actually. But I definitely can't do that here, because I need to be able to insert an element in front of the end pointer without having the list. That is my 0.6. So if the pointer is pointing to nothing, to a null pointer, then we have no clue what to do. Can't insert anything in front of it then. I'm inclined to make it a node pointer actually, and then use casts here to the. By the time you dereference it, it must be the base class of the actual value type. But I think I'm going to use this thing to point to something that's just a node and not a value type. It's probably more safe than to make the pointer a node to begin with. So the node still has the next pointer, obviously, and the previous pointer. We just need a cast here. And that can be static cast. We'll make it a static cast for the pointer. Which is only possible if value type is already defined as being derived from node, but that is the case because it's defined up here. So you can do a static cast from node to value type in that case. That's allowed. That is, node is protected. Yeah, this should be possible. What was I working on? I don't know anymore. Let me just try to compile it again. Invalid initialization of reference of type value reference from expression of type node. I need a cast there as well then. Yeah, because yeah, okay. Where's my line number? Yeah. So I'm still needing a cast. Static cast pointer looks a lot better, doesn't it? I should do that here as well. It's even the thing that we are returning. I could also do a static cast to a reference of the dereferenced pointer. Compile. An instantiation of operator star required from here. The node is an inaccessible base. Again. So the static cast is not allowed. Oh, because I'm doing it here. Yeah. No, then we have to add that friend anyway. Because now we're doing a static cast here, also the iterator must be a friend. What is now required from in instantiation of next required from here could not convert from value type pointer to const iterator. Okay, I thought I added that constructor. This is a candidate or not? Candidate. Candidate utils list. Consider, yeah, it's a default constructor. No, I can't need it. Const iterator reference. That's just a copy constructor. No conversion. Const iterator. The move constructor. Did I not add it? Maybe I got distracted. I just did not add it. Indeed, I just added the default constructor. I added the default constructor, but not the explicit constructor for the node pointer yet. Nope, still nothing. Still in next. Could not convert from value type pointer to const iterator. From value type pointer. Oh, because a value type pointer cannot be converted to a node pointer, because a node is a protected base class. That means that we should accept a value type pointer and not a node pointer, and then somehow fix that. So take a value type pointer. Now we have a problem here, because wait a minute. No, this is const iterator, which is a friend. So the friend does have access to the node. So now it should work. Except that it doesn't, because so really, it's going from value type pointer to const iterator. I just added it. No, I didn't. This is an assignment. And the constructor is explicit, so that doesn't work. This is a copy assignment though, but still. I think it just doesn't work because it is explicit. So let's edit this. Wait a minute. No, that's nonsense. Wait a minute. Next. That is in instantiation required from. That's not interesting. So we're here cannot convert from value type pointer to const iterator. That is here. Oh, this is a normal iterator. That is majorly nasty. I think I get it. So the problem is that this constructor, we're trying to use an explicit constructor of iterator here. But next is a pointer. Sorry, so that still doesn't work. I just have to cast this to value type pointer first, which was just a call to next. Can I just call next here? Next. No, because I'm implementing next. Yeah, right here. Oops. Okay. Yeah, then I'll have to do a static cost, I think. Static costs to the value type. We are inside value type. What the hell? No, yeah, I can just. Can I use value type? I don't think I can use value type actually. Yeah. That's maybe we can try it. I'm not sure. Nix was not declared in this scope. Still needed this. Still not good. Could not convert. Next from. Next is value type pointer. No. Sorry. What? I did physics, Jacob. That's what you mean. What the hell is this? Oh, the cast is already there. So the cast worked, and the next is of course a node pointer, but the cast is then in front of that, so could not convert a value type pointer to const iterator, which is weird because I'm now definitely sure that I added an a constructor of that. But yeah, it is explicit, so maybe that's the reason. And this happens here and here. 57 and 59. (57) and 59, yeah. So it does not happen for the const iterator. I think if I comment this out, then it should compile. So the problem is actually that the iterator itself the class iterator is doing what? I was sure I had that. So that's the problem that I had in mind doesn't exist. Yeah, using const iterator. already had that. Just inherit or use the constructors of the base class. So now it compiles. Good. That means that we have this is having just the value time as we possibly access the previous next elements. We already had that. Okay. What was the next point? Oh yeah, it must be testable if an iterator is the end iterator. Let me copy the other things as well. What do we have there? So normally you do something like I mean, we have one element in our list, so iter should not equal end. Yeah, so we should normally you do something like L end. But now I use the L, the list. Okay, but let's begin with this. Now we use the list, but this of course should work. And not assert. Pretty sure here, yeah, everything will go wrong. No match for operator unequals to begin with, the iterator. Let's see, I had that here as well, that it would, these two have to be declared apparently. I'm just going to implement this again in terms of the const iterator. So that would be just static cast thing, or can I wait a minute. To be honest, I don't like the binary operators to be member functions. I want them to be free functions. Should do the right hand side and the left hand side. So an iterator can seamlessly be converted to a const iterator, so maybe I don't even need to define these things. If you try to compare an iterator with something that and only the operators for const iterator exist, and that will work already. So I don't even need these things. Let's put them here in the const iterator. Yeah, and that is just comparing the pointer, right? Oh. If I make it a friend, then it cannot be const anymore. Undefined reference to end. Never implemented these things. Yeah, now I have to seriously think about how to implement the fact that I want it to be testable, that it is end, without having the list, but still being able to insert something in front of it, while the size is equal to a single pointer. Aha. Well, I had something in mind from the beginning, and that has to do with alignment. Our pointers, any pointer is usually aligned to 8 bytes. Isn't it? Well, certainly, since we have now our value type. I mean, our pointers are value type pointers, right? Yeah, value type pointers. And the value types are derived from node. And the node contains pointers. And pointers are then aligned to the size of a pointer, which is 8 byte. Therefore, let's put node first. Or it doesn't really matter, actually. I mean, it's still going to be aligned. Maybe it's smarter to put node first. Let's say, no, it doesn't really matter the way you put it. I mean, if this is not integer number of the size of a pointer, then we are going to have empty bytes in front of it. Say t is just a char, a character. Then we'll have a char here and then 7 empty chars to make it in total of 8. And then we get the node, which consists of 2 things. So in total we have then 24 bytes to store a single char. But if you reverse them, then you would have something with the size of 24 still, even though you would have first the node, so we would first have 8 bytes, again 8 bytes, and then a single byte. The size of something must be a multiple of the alignment, and the alignment is going to be 8 bytes. So the size of the value type is going to be 24 no matter how you order these things. And for some reason I like the value type to not just be a type, but be the type in the memory layout, as in the type T of the user must be the very first thing. So even if they would C-cast it to a T, then it's still correct. Yeah, so the node is the one that has the offset. And that's okay. But at the same time, we know that the alignment of the value type is at least 8. So what I wanted to do was somehow force a misaligned pointer in these things, which I'm not sure is possible. I can do a mem copy, I think. You can make up. I can take the pointer to previous or next and then cast that to a character pointer and then write to that, which is allowed, I think, by the standard, because character pointers are special in that case. You're not allowed to just you're not even allowed to have a union of two different types and then write to one member of the union and read the other one. But there is an exception for character pointers. So if you cast a memory region to a character pointer and then write to it with the memcopy, then you are allowed to read it as the other type, as far as I know. So that way we should be able to get a non-aligned value in a pointer, and I'm pointing here, but I'm meaning the pointer of the iterator, so this one. The point being that the node itself is aligned by 8 bytes. So if you put an odd number in this, then it's something special. And we can use that specialness to detect that it is the begin or end pointer. So what I want to do is, I think I'm going to add a node in the list itself, and then make a circular list where the end pointer simply points to the node of the list, and the begin pointer, the previous of the begin pointer, sorry, the previous of the first element of the list points to the node of the list, but not directly, but with some offset, so we can detect it, that is the case. Which then makes it a tiny little bit slower to access these things, because we constantly have to do a bitwise AND on the pointers to get the real value. At least for the begin one, that would be the case. If I want to, yeah. No, I can test it in a different way, actually. An iterator. I can test if an iterator is the begin iterator without having the list in a very nasty way. First, I test that it's not end. When it's not end, we can dereference it, and when we dereference it, we get the value type, and the value type contains the node. So then we have these pointers, and then we can set previous to null in the case that it is the first one, the first element, which is not okay, actually. That is not okay. No, wait a minute. If you want to insert an element before that point, we still need to have the previous node. Maybe I can mark the next pointer then. But yeah, then if I do that, then we still have to continuously I mean, it's possible by making it odd or adding 1 or 2 to it. But I want to do it in such a way that we don't have to do a bitwise AND all the time. So maybe leave these two alone, actually, and only corrupt the iterators itself. I mean, the iterator must be corrupted anyway in order to mark an AND iterator. So, yeah. it is so annoying that you're not allowed to write to use a that you're not allowed to use a union for that. Think about this. So I would like to make this a union. It's still the easiest way, I think. It's very, very, very hard to make a pointer, to turn a pointer into an integer and back. So let's make this a union. Let's ask a stupid question. Which C++20 type or integral type has the same size as a pointer? I think a pointer div type or something, probably. Int pointer type that exists. I didn't know that was allowed. Can you just reinterpret cast it? Yeah, in that case I wouldn't even need a union. But I'm not convinced you can do that actually. So let's try this first without writing too much code. Okay, so no union yet. Yeah, so let's make an let's make a constructor that allows constructing the end pointer. The end iterator. Yeah, it's also explicit, but nah. Well, of course you have to pass the list. So we have a list here. The const iterator itself, you would say, could have a const list. We should be able to. You should be able to construct a const iterator from a const list, I suppose. But I'm abusing the same thing, the same constructors for iterator. In that case, it's definitely not the case. I think we just need both. So I can make a. I think I should only allow to make a const iterator from a const list. You can't use list. Oh, of course, I can use list. I'm gonna implement that below. I might as well have inlined it maybe. No, I don't know. Let's put it here. So the only thing that const iterator has is a pointer. And we want to initialize that with okay, wait a minute. The pointer is a node pointer, which is the base class or inaccessible base class of a value type. No, my list just has a node. How do you call that node? A base? Base node, whatever. Yeah, what? It's a pointer to the base node. Yeah, so the list itself contains a node called base node. Which also must be initialized. But this is a fake node. So it's just a node, it's not a value type. So if you construct a list like this, it's always empty. Yeah, well, unless you do that, but you still have to implement that one. These two don't mention it, so we can do that here, and then we have to fill that with pointers to itself. So now the base node is initialized with the previous and next pointer that point to itself. However, this is a value type pointer. Why did I do that again? Yeah, I don't know. That's just not really true then. Well, not in this case. I mean, I can make this node pointers, but then I have to do a lot of static cast from node to value type, I guess. So I have to make the decision if we want that. So the pointer is a node pointer, so I might as well make next then also a node pointer. That's the only thing that we're doing with it, just assigning it there. And here I already have a static cast. What? This next? Is it another next? No. I don't know. I get the feeling that maybe I should have made this just a node. Why not? That should still work. That should still work. And this time would only work if I make the change the const iterator to take a node pointer. And why not? Because it is a node pointer. That thing. It still compiles, but still undefined end, but the rest, no problem. So now we have a constructor from a list, which is an iterator that points to the base node. See, I could make the iterators simple contain normal pointers. And then we can dereference it anyway to a node, because also the base node is a node. So we do have the previous index pointer, and then it is detectable that it is the end if something. To struct node. Then there must be something special about the base node, so we can recognize it. Hello, Mr. Null. I can think of a very, 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 very nasty thing. Oh, that's just, no. It's too bad. It's too bad. I was thinking we could put because the size of a value type is always 24 bytes, right? No matter what the type of the user is. I could just put here an 8-byte magic number. And then you can detect that a node is this node by just reading the memory after the node. And then if it is equal to the magic number, it must be the base node. That, of course, does mean that if the user would make... before it. But that doesn't matter. So the user could still make store data and then store the magic number, and then everything would break down. But if you pick a good magic number, then that's never going to happen, unless on purpose. But yeah, I don't know. It feels a bit very, very dirty. But it would be a lot faster than... Would it be faster? It probably will be faster, I think, than doing the... No, I'm not too sure, actually. Let's just do... Let's just abuse the last bits of these pointers. So what I want to do here is store... Which shall I abuse next? Previous or next? Let's do previous. So I'm going to make a function. Taint. Is that a good word? Meaning in Tamil. What the hell, dude? Taint meat? I'll just type it, dude. Taint. A trace of a bad or undesirable substance. Contaminated pollutant. Yeah. I think that's what I meant. So let's call it taint. Well, I have to ask on IRC if this is undefined behavior or not. I guess if it compiles it, it can't really be. Let's first try if it compiles. Invalid static cast. Yeah, I need to reinterpret cast, of course. No, it compiles. Okay, so the AND iterator points to this node. Yep, so We can make an, you can change this node. And then we can add in the iterator simply a test is int. And the tainted is then part of the node. So that is the pointer then. Yep. So if the pointer points to a tainted node, and then the iterator is actually the end iterator. And we also wanted to be able to test if it is begin. So begin means that the previous thing is tainted, except when it is end. I think should we, if begin equals end, sorry, if the list is empty, then is begin equal to end? So is it then begin or not? So an iterator that is end, can that also be begin at the same time? I don't think so. Nah. So if an iterator is end, and I ask is it begin, then it should return false, I think. So the only correct way to do this is, I'm going to define it here, therefore, that it is not end. And when it is not end, it is dereferenceable. Therefore, we can do pointer previous. Sorry, pointer previous is tainted, which would work anyway. It doesn't have to be dereferenceable for that. Dereferenceable for that. So pointer is a node pointer, which points then to a node which is no longer the base node. Therefore, well, actually, it is dereferenceable because of that. Because it's a not node, it contains a previous that is not tainted, right? Yeah. So I can dereference previous directly. And if then previous points to a node whose previous is tainted, then this is begin. And we can also implement end at the moment. We'll finally implement this. On one hand, I want to do everything below, but then we have so many template stuff. So maybe I should do it just inline here. Your implementation of end. Well, that then must return something that returns, that passes the list. which is, oh, yeah, that is this. This is, of course, the list. That is, I added to const iterator a constructor that accepts a const reference to a list. An iterator inherits all the constructors of the const iterator base clause. So it does accept a const reference to the list as well. Something feels wrong though, but I think it just works. Same here. I cannot believe that there's no accept here, actually. Return constructed from the list. Yeah, and this is just an overload that is that you can use if you have a non-const list, but you want a const iterator anyway. An instantiation constructor of const iterator from a list required from end, required from here, invalid conversion from node pointer to node pointer. Oh, stupid people! Why do they put the const on the right? Just write const pointer. Okay, so we cannot go from a node const pointer to a node pointer. Yeah, okay. And I probably need a const cast here, but let's check what this exactly happens. So this is a non-const pointer, and base node is const here because list is const probably. So we need to look here. Yeah. So you can construct a const iterator from a const list. Either way, my pointer is not const, so I'll just have to cast it. Let's test. Well, this compiles. Let's see if it indeed is unequal L enter, or that we don't crash at all. I haven't run this thing in a long time, if you ask me. Yeah, record dump. I only checked if it compiled. Pointer, we're trying to dereference a null pointer. Y operator plus plus. No, I'm having a null pointer iterator, which should never happen. How do I even get that thing? So this is iter. Well, I'll probably just default constructed it. iter. No, it's L begin. I never implemented begin. I didn't. So what the hell? Oh, now I'm completely lost. Yeah, there we are. I did make a begin. Oh, I just filled in something because it had a return type. Okay. We need to implement a constructor for begin. For iterator. That is the begin. The current work of today is nothing to do with gradient descent, and you can Google gradient descent to find out what it is. It has to do with minimizing the loss function of a neural network. Return okay, we need to construct an iterator, or let's begin with the const iterator again. Class const iterator, yes. Okay, we can just construct it again from a node pointer, and then this must point, of course, to the first element. Okay, that's easy. Yeah, that's easy. So we just have this is the list. So our list has a base node. And then we need the next pointer of the base node, because that points to the first element. Which is a node pointer, and I can construct a const iterator from a node pointer. Pretty sure of that. Actually, yeah, here. So you can just, if you pass a node pointer to, where the node pointer points to the base class of the first element, then everything should be okay. And this is the first element, right? Base node next. And list is just this object here. Hopefully that works for both cases. Of course it doesn't. An instantiation of begin required from here. Converting to iterator from initializer list would use explicit constructor. Iterator node pointer inherited from. Okay, it is explicit. Yeah, forgot about that. So you have to do the same thing. Have to tell it which type it is. And now it compiles and links. I mean, list tests, and it still dumps. Great. Otherwise, you wouldn't have anything to do. In half an hour, the shop closes, and I still have to buy dinner. Just a warning. Or I can just make this wait till the shop closed, and then I can buy Chinese because they are open till 10 o'clock. No, it should follow directory. Sick abort. Core dump. Iter is unequal L end. That's interesting. Why would that be equal then? Oh, because I never implement. The list is empty, so I never implemented the pushback. It's just the same thing. Quit. So iterators L begin, and of course that is going to be equal to end, unless the list is not empty. And I didn't push back, but that's not implemented. So yeah, it remains empty. Nothing. Doesn't do anything. How many other empty things do I have? Just put an assert false in here, so get alerted when something that is not implemented yet is being used. I think this one is correct. The rest seems to be implemented. Splice, utils list. Okay. So most of them are not implemented and will not link because they're just empty. They're not really implemented. They're just declared. I don't have any empty things anymore. I think that was the last one. Yeah. So let's just implement it. Push back. It's not that easy actually. It needs to use the allocator. Claude, help me. Rotational pushback for a list class typically involves creating a new node with the given value and adding it to the end of the list. It's a common implementation pattern. Pushback, create a new node. If this empty, the list is empty, the new node becomes both head and tail. Nah, already have that. Otherwise, add a new node after the current tail. Increment the size. So, yeah, we probably need the size as well. Yeah. To create node is what I wanted to know. This. Alloc traits construct. Okay, so we need an empty. I need an empty and a size to begin with. Let's add the size first. No, I don't like this. Just put it here. Going to implement those. Isn't like the fastest way to check if a list is empty not just then look at the size? So instead of looking if the base node points to itself? Probably even faster. So why not? Oops. Empty is equal to 0. Gosh. Push back. Oh, I'm not sure I need to do anything special though for when the list is empty. Okay, let's begin with creating a new node. Actually, let's begin with creating a new value type. Value type. I'll add it if that is needed. Create node value. Yeah, probably need to create node in other functions besides pushback as well. Push front, for example. So we're going to have a separate create node thing. And then it must be inserted. I feel much for just inserting it with a more general insert thing. Now more stuff, but no, wait a minute. Need to implement create node. Void? what was the void doing there? Create node, create node, create node, create node. Look, it feels very, very, very static. This one is not static, why not? Create node, this allocate. Construct this. Treat new nodes. To make it static. Static until proven otherwise. Or yeah, okay, something like that, huh? And I just want to know if this compiles. Seems to compile. Undefined reference to create node. I thought I had it. Yep, I added something. But it's not a member function. Okay, it compiles. So all those this pointers were not needed. And then, yeah, it must be inserted. Okay, let me think. Basically, that means that it's pushed back, right? So, I think I don't give a shit about value type though. Might as well use a node type here. Although maybe that doesn't work because let's see, create node should create a value type but then return a node type. At least then we have access to everything. And then we want, it's at the end, so the next pointer must always point to the list base. Base node. And the previous pointer must point to the thing that is at the end of the list at this moment, which is base node next. No, that would be the first one. Sorry, must be previous. Which might be tainted, and so we have to untaint it. Okay. And then the base node previous must be updated to point to new node. Already used base node previous now, so we can do base node previous is change new node. And now we need one more. The thing that was at the end, which is actually what this thing is pointing to. So it's a base node previous untainted, which I already have here. New node previous next is new node. Yeah, looks good to me. So, still have to implement untainted. I could do -1 here, just to screw with attempts to untaint something that wasn't tainted. Or is that nonsense? Let's try that. I think we get a bus error if you try to access something through an OR pointer. Node declaration matches create node. Oh, I have to add it. $13 till the shops close. Shop closes. I think I'm going to create node, return null pointer. Yeah, okay. Might as well go now. Otherwise it will be closed. I'll be back later.